Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to walk you through every single problem on our first polynomials test review about imaginary numbers, factoring, and writing polynomial equations given the roots. My disclaimer is always I need you guys to work these problems on your own and then go to the video and iron out any misunderstandings or mistakes that you might have made. So let's jump right into it. So in these first few problems, we are being asked to solve these following quadratics by factoring, and I'll just point out here, notice that all four of these problems have an equal sign, okay? So we're actually solving the entire equation and getting our roots, getting our solutions, getting our x-intercepts. Okay, so the first thing I always want to do is see, can I pull out a GCF? And also look and make sure I'm in standard form. Okay, so let's rewrite this in standard form. I always want to make sure that the ax squared term is the positive, so I want to move the 12 to the side. So I've got 2x squared minus 5x minus 12 equals 0. Okay, can I pull out a GCF? No, I can't. Okay, so then I'm going to look to see how am I going to factor this? Well, a is not 1. Okay, so if a is not 1, I have to do the rainbow thing. I have to multiply a times c, 2 times negative 12, that's going to give me this temporary number, negative 24, and I got to see what are the factors of negative 24 that add to this middle term, negative 5. Now it's going to break down into 8 and 3, but which one has to be negative? The middle term sign tells you the sign of the bigger one, so since the 5 is negative, the bigger one has to be negative, so this is going to break down in negative 8 and positive 3. So I'm going to split this middle term. Okay, I'll put the 8 with the 2. That makes more sense to me. Negative 8x, I'll put 3x. I'll match that up with the minus 12. 3x minus 12. And then now I have 4 terms. I'm ready to draw my curtain and group. So pull out the GCF on the left. I can pull out a 2x. That's going to leave me with x minus 4. The GCF over here is 3. That better leave me with x minus 4. 3x, negative 12. Yep, it does. Alright, so now one of my factors is the matching binomial, so I have x minus 4. My other factor is going to be the stuff left over on the outside, 2x plus 3. Remember, this is set equal to 0. Okay, so I actually have to solve this. So here, when this coefficient in the binomial is a 1, you just flip the sign. So one of my zeros is going to be positive 4, and then 2x plus 3. Y'all should be able to do this in your head by now. Move the 3 to the other side, divided by 2. My other solution is going to be negative 3/2. Okay. All right, so you may ask yourself, I've shown you guys a little trick where if you don't have an equation where they just ask you to factor, say they just asked you to factor this. Okay, so I've shown you the trick where you type this in your calculator, get a number, and you type in your two binomials and get a number, make sure they match. Well, what happens when I have an equation set equal to 0? You can still do that. You can type in the original expression, type in your two factors, and make sure they equal each other. If you want to type it in to the entire equation, how do I do negative 3/2? Well, that's quite simple. Let me zoom out a little bit so you guys can see my calculator here. Okay, so I'm going to type it into my equation. I'm going to go ahead and type it into the equation set equals 0 here. So I'm going to plug in negative 3. 4 is easy. Just type in 4 everywhere you see an x. But what if both of my factors are fractions? That's fine. I'm going to type in 2x squared. My x is negative 3/2, so negative 3 divided by 2. 2x squared, so I'm going to square that, minus 5 times negative 3/2. Okay, minus 12, and that better equal what? Okay, that better equal 0. And it does. So there you go. That's a way to check your answer for the equations. Okay, let's keep going. Second one over here, I've got 4x squared minus 81. The first thing I notice is I only have 2 terms. So if I only have 2 terms, I'm thinking this is probably a difference of squares, and it is. Can I take the square root of 4x squared? Let me zoom back in. Can I take the square root of 4x squared? Well, yes, I can. Can I take the square root of 81? Yes, I can. Is there a minus sign in between there? Yes, there is. So this is a difference of squares. So one of my factors is positive, one of my factors is negative. Okay, so if I set each one of these equal to 0, for this one here, if I just move the 9 to the other side, make that a negative 9 divided by 2, I will get x is equal to negative 9/2. For this one, move the 9 to the side, positive 9 divided by 2, I'll get a positive 9/2. Okay. Okay. But notice, I want to take just a second here. Notice 4x squared. We could have done this just as easy solving this using the square root method that we learned last year in geometry. If I move the 81 to the other side, get x by itself, I got x squared is equal to 81 over 4. If I take the square root of both sides, I get x is equal to the square root of 81 over 4. Whenever I take the square root of a number, I always generate a plus or minus. Square root of 81 over 4 is just 9 halves. So plus or minus 9 halves, plus or minus 9 halves. Okay. All right, so the next one here, this is easy. I'm factoring a trinomial where a equals 1. So I just look to see what are the factors of negative 35 that add to negative 2. That's going to be a 7 and a 5, and since the middle term is negative, the higher number is going to be negative, so the 7 has to be negative. So factors is x minus 7 times x plus 5. The coefficients are both 1, so all I do is flippy-flip. Just flip the signs. 7 and negative 5 are my solutions, my roots, my zeros. Okay, the next one, once again, I got to have it set equal to 0. So let's move these two terms to the other side. So I'll have 15x squared plus 7x minus 2 equals 0. I'm in standard form. Okay, a is not 1, so I've got to do the rainbow thing again. Multiply a times c. 15 times negative 2 is negative 30. What are the factors of negative 30 that add to a 7? Well, always think, what are the first two numbers that pop in your head when you think of 30 multiplying? I think of 3 and 10, right? Are those 7 apart? Yes, they are. Okay, so it's going to break down into 7. It's going to break down into 3 and 10. Which one has to be positive? Well, the bigger one is positive, so this is going to be positive 10 and a negative 3. I will choose to match the 10 with the 15. That makes sense to me. But it doesn't matter. 15x squared plus 10x. I'll put the negative 3x over here minus the 2. Let's draw our curtain and pull out a GCF. I can pull out a 5x. That will leave me with x plus, oops, excuse me, 5x. That's going to leave me with 3x plus 2. Here, guys, that front sign is a negative. If that guy right there is a negative, you must pull out the negative. In this case, all I can do is pull out a negative 1. That better leave me with 3x plus 2. Yep, check, check, check. Make sure that the signs are right. So one of my factors is the matching binomial, 3x plus 2. My other factor is the stuff left over on the outside, 5x minus 1 equals 0. Okay, you guys should be able to do this in your head. Move the 2 to the other side, negative 2 divided by 3. So I've got negative 2/3, move the 1 to the other side, positive 1 divided by 5, and a positive 1/5. So negative 2/3 and positive 1/5. Okay. Once again, this will be probably the last time I do this with a fraction. I can type. Now, obviously, ideally, you'd like to have time to type both of these in and make sure they both equal 0. I'll do the 1/5. Okay, so on my calculator, let me zoom back out here real quick. All right, so my calculator, I'm going to plug it into my standard form, set equals 0. So I got 15 parentheses 1 divided by 5 squared plus 7 parentheses 1 divided by 5 minus 2. I better equal 0. Huh? It does. Okay. Check, check, check. Always check your work. Check, check, check. It'll save your life. Okay, the next 4, we were asked to solve the following quadratics using the quadratic formula. Well, some of you guys probably look at this and immediately say, oh, I can pull out a GCF of 2. You know, that's correct. We could factor this, okay, but they're asking us to use the quadratic formulas. So we say, okay, fine, we can do that. So again, I always want my quadratic set equal to 0. So I've got 2x squared plus 12x minus 144 equals 0. I'm a big believer in coming out here to the side and listing your A's and B's and C's. A is 2, B is 12, C is negative 144. Okay, just write those down so you don't have to think about it anymore. Quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so negative 12 plus or minus. Now here, again, me personally, I just go ahead and type all that into my calculator and get a number exactly the way I see it. So I'll just do 12 squared minus 4 times 2 times negative 144. Okay, I get 1296. Okay, so it's plus or minus the square root, 1296 all over 2 times 2, which is 4. Okay, so you guys immediately, I know you guys are immediately thinking, oh my gosh, that's a big number. How am I going to break down this huge radical? Okay, well, first of all, by the way, let's see if that is a perfect square. Can I take the square root of 1296? Oop, I can. That is a perfect square. However, for those of you who are going to a calculator, okay, so how do I figure out how this breaks down? The way I taught you is go y equals, type in the big number, 1296, divided by x, second table. And I'm looking for the highest perfect square that goes into that number, okay? So if you scroll down here, keep scrolling, there you go. Some of you guys probably stopped here and you saw 144 and 9. So you would say, okay, the square root of 1296 breaks down into the square root of 9 times the square root of 144. But notice both of these are already perfect squares. When you break down this radical, only one of them is a perfect square. If both of them are perfect squares, that is a perfect square, okay? That just breaks down into 3 times 12, which is 36, which, by the way, that's what we said. The square root of 1296 is 36. Okay, so this makes this a little bit easier. So I have negative 12 plus or minus 36 all over 4. Okay, well, I have two answers. One of my answers is negative 12 plus 36 over 4, okay, which is, that's going to be, that's 24 over 4, that's just 6. X is equal to 6. My other answer is going to be negative 12 minus the 36 over 4. Negative 12 minus 36 is negative 48. Negative 48 divided by 4 is negative 12. Okay, so I believe I went over this in class. If you solve a quadratic equation with the quadratic formula, or completing the square, and your numbers are integers, whole numbers, or fractions, that means you could have factored it. The only way that when you have to solve a quadratic equation and you're forced to use the quadratic formula or completing the square, you're always going to have an irrational answer. You're going to have some kind of square root answer or some kind of decimal in your final answer. Okay, let's go to the next one. Quadratic formula. Let's set this guy equals 0, 7x squared. Now, this is a typo. I'm not sure. I'm using a file from last year. Whoever created this didn't catch that those are two different variables. Let's use an x. Okay, so 7x squared plus 2x plus 9 is equal to 0. All right, so let's come out here to the side. My a is 7, my b is 2, my c is 9. Negative b plus or minus the square root of b squared. Now remember, if your b is negative, guys, make sure you put that in parentheses, okay? But it's positive, so it doesn't matter. B squared minus 4 times a times c all over 2 times a. Oops. 2 times a, which is 7. Okay. So I have negative 2 plus or minus. Again, I just type all that in my calculator. 2 squared minus 4 times 7 times 9. I get negative 248. Okay. Negative 248 all over 2 times 7, which is 14. All right, so the first thing that you guys should notice, I'm going to pull this up here. The first thing you should notice is I have a negative inside the radical. And up until this year, up until this point, we've been saying no real solutions, and that's correct. But now we have solutions. They're just imaginary. So when you see that negative inside the radical, the square root of negative 248 is the same thing as the square root of negative 1 times the square root of 248. And by definition, the square root of negative 1 is I. So that's why when you have a negative in the radical, then that I pops out. So I have negative 2 plus or minus I times the square root of positive 248 all over 14. But I still got to figure out how does 248 break down. So let's go to my calculator. Zoom out. Y equals 248 divided by x. Second table. Okay. And by the way, guys, some of you guys have some weird values in your table. Sometimes you guys have really weird increments. If your table is not going up by increments of 1, you see this in blue, table set. If you go second table set, you want to make sure that your table always starts at 0. and you want your increment, this delta table, you want the increment to be 1. You don't want to go up at increments of 0.5 or increments of 10. So if your table's out of whack, just go second table and make sure this is where you want it. I want to start at 0 and go up at increments of 1. Okay. So let's see what is the highest perfect square that goes into 248. And normally, guys, we're looking in the y column. Okay, but I don't see any perfect squares here. If I scroll down in the y column, I don't see any numbers that are perfect squares. Okay, so you might think, well, I guess that means I can't break it down, but you can. So if there are no perfect squares in the y column, let's just go back to our normal perfect squares in the x column. 4 is a perfect square, so 4 and 62. What about 9? No, that gives me a decimal. What about 16? No, decimal. 25, and then of course at this point we can say, okay, this is going to break down into the square root of 4 and the square root of 62. Zoom back in. Okay, so the square root, let me just kind of do this up here. Square root of 248 breaks down into the square root of 4 times the square root of 62, and the square root of 4 is just 2, so that's 2 root 62. Okay, but remember we got this I sitting out front. So I'm going to bring everything else down. I got -2 plus or minus 2 root 62, but I have an I sitting out front, so that's plus or minus 2I root 62 all over 14. And then once again, notice that all three of these guys are all divisible by 2, so if I divide all those by 2, my final answer is -1 plus or minus I root 62 all over 7. Okay. -1 plus or minus I 62 root 62 over 7. You might be saying, oh, Mr. Meese, can I check that on my calculator? Yeah, you sure can. I'm going to show you how to do it. It doesn't matter that there are I's in there. It doesn't matter. Actually, maybe I need to back up a good bit. Okay. All right, so let's type in, all of this is an answer, right? I have 2 answers. Let's just get an answer. I just want to get a number in my calculator. Let's just go ahead and type in -1 plus second I, your I button's down here above the, you can't see that, above the decimal. There's your I right there in blue. Okay, so let's go -1. Trying to make sure you guys can see this on the camera. -1 plus I second root 62. Okay, let's just go ahead and press enter, and then we're going to divide that by 7, so divided by 7. Okay, that's one of our solutions, some decimal. -0.1 blah 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 plus 1.1 blah blah I. Fine, whatever. I don't care what that number is. Okay, that's one of our answers. Okay, so I'm going to plug that answer back into my original equation. Okay, so it's 7. Okay, so it's 7 times our answer, so go second answer squared, that is 7x squared, plus 2 times x, second answer, plus 9, and that better be equal to 0. Okay, so it doesn't matter that you got i's in your final equation. You plug this back in for x, this equation better hold true. Okay, so just more ways to check your answer. Okay, let's keep going. Well, let's maybe speed up here just a bit. Okay, so quadratic formula, I've got a equals 11, b equals 4, c equals 10. So I got -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, that comes out to be -4 plus or minus. I'm not going to show you guys that. I'll just tell you the number. The number is -424 all over 22. Okay, so once again, I will show you this real quick. Okay, y equals, let's type in the number, 424 divided by x. You don't have to type in the negative, guys. That doesn't matter. I'm just looking for 2 numbers. I'm looking for a perfect square and another number. Okay, so I start at 0 here. Okay, I don't see any perfect squares there. Okay, don't see any perfect squares. Maybe we're going to have to do what we did on the last one. Okay, well, there you go. 4 is a perfect square in 106. Okay, so the square root, let me do this over here on the side. The square root of 424 breaks down into the square root of 4 times the square root of 106, which is 2 root 106. Okay, but once again, I have this negative. I'm sorry, I keep focusing. I just want to make sure you guys can see everything. But I got this negative out front, so an I pops out. Okay, so I got -4 plus or minus the I. Okay, but I got this 2 root 106, so it's 2I root 106 all over the 22. Okay, and once again, all three of these guys are divisible by 2. So that's -2 plus or minus I root 106 all over 11. Okay, so take that answer, plug this into your calculator, get some number, and then stick that back in for x and make sure it equals 0. Okay, 11x squared minus x, move that 4 to the other side. A equals 11, B equals -1, C equals -4. So I got negative b, so that's a -1, plus or minus the square root of b squared. Now you got to put that in parentheses. I know it's 1, but it's still a negative being squared. -4 times a times c all over 2 times a. Negative, negative makes that a positive. Okay, type this in your calculator. Okay, now if I do this, I got to put that, I know you guys can do that in your head in 3 milliseconds, okay, but in case that were a bigger number, -1 squared minus 4 times 11 times -4. Get a number, okay, 177 under the radical. Okay, 177 under the radical all over 2 times 11, which is 22. Okay, 177, does that break down? It ends in 7, which is kind of one of those weird ending numbers, so I'm already thinking, probably not if it ends in 7. So 177 divided by x, second table, and yeah, we got nothing, nada. No, you're hardly any whole numbers at all, right? Numbers that end in 1 and end in 7, you know, those aren't as easily divisible. Okay, so that's my answer. 1 plus or minus the square root of 177 over 22. X equals, technically. Okay, let's move on from the quadratic formula. Let's move on to the I stuff. All right, now guys, on the test, quiz and test, adding and subtracting, honestly, I really don't need to see the work there. I do need to see the work when you're foiling it out and you're doing multiplying by the conjugates when you're dividing. On this stuff, a lot of you guys can just do this in your head, so I'm subtracting. Now don't remember, now this is not foiling. A lot of you guys made that mistake on the quiz. You multiplied these. No sign there, that's multiplication, but there is a sign there. That's just combining like terms. So this is 2 minus 8i plus 3 plus 9i, and that is going to be equal to 2 plus 3, and then -8i plus 9i is just positive I. Can I check that on my calculator? You bet. I'm not going to do all these, but I really want to hammer this point home, guys. No excuse for missing these questions when I've taught you how to check these. 2 minus 8 second I minus parentheses -3 minus 9 second I. Oh look, 5 plus I. You can check every single one of these. Okay, the next one, I to the 14th. Yeah, you can just type that in your calculator. Second I raised to the 14th. Yeah, you can get a number. Now notice here, what in the world is this mess? This is saying -1 minus 4e to the -13i. Again, I told you guys this in class. This is a Texas Instrument glitch from the best I can tell. This is basically -1 minus 4 with 0.13 zeros, 0.00000000I. Well, guess what? That's basically 0. So basically, your answer is -1. Okay. So just in case you guys are typing that in your calculator, you don't know how to interpret these wacky answers. But what I need to see on the test, I need to see that you understand every fourth multiple. Every exponent that's divisible by 4 is just 1. I to the 4th is 1. I to the 8th is 1. I to the 100th is 1. So I need to see you break this down into I to the 12th times I squared. 2 plus 12 is 14. Anything divisible by 4 is just 1. Okay, and then I squared, by definition, we know is -1, which is exactly the same thing that our calculator gave us, except this wacky stuff on the end. Okay. All right, next one. Distribute here. Negative 2i times negative 5 is negative 10i. 2i times negative 9i, get the sign right first. 2i times 9i is minus 18i squared. But remember, I squared by definition is negative 1. So negative 1 times a negative 18, that's going to give me a positive 18 minus the 10i. And yes, we always want to write the real number first and then the imaginary piece. Okay, the conjugate. Dividing. When I'm dividing, I must multiply the top and the bottom by the conjugate. The conjugate just means you're multiplying by the same thing, you just flip that sign. Okay, so I'm going to be multiplying by 2 minus 3i over 2 minus 3i. 2 minus 3i over 2 minus 3i is just 1. So all I've done is I've just multiplied this guy by 1. Okay, but now when I FOIL this out, okay, on the top I'm going to have 18 minus 27i inside minus 2i last. Now that's going to give me a negative times a negative is a positive. I times 3i is 3i squared. Okay, but again, I squared is negative 1, so that's going to change that back to a negative. Okay. All right, so on the bottom, I'll combine like terms in just a second. On the bottom, when I FOIL this out, this is a difference of squares. So when you multiply by the conjugate on the bottom, and you have two terms there, it's always going to be a difference of squares. I'll do that real quick. 2 times 2 is 4. 2 times negative 3i is minus 6i. 3i times 2 is plus 6i. 3i times negative 3i is negative 9i squared. But notice that these two guys in the middle, they will always cancel, always, when you have the difference of squares. I squared is negative 1, so that makes that a positive 9. Okay, so on the bottom, I basically just have 4 plus 9, which is just 13. Okay. All right, so let me combine my like terms on the top. 3i squared is negative, that's going to be a negative 3. 18 minus 3 is going to give me a 15. Negative 27i minus 2i is minus 29i. And then we have this all over 13. Okay, let me check it real quick. Back out. Okay, type in the original problem exactly the way you see it. Now you got to put those in parentheses. Okay, parentheses 9 minus second I divided by 2 plus 3, oops, I. Okay, get a number. Oops, type something wrong. Yep, I forgot the parentheses. 9 minus I, close the parentheses. 2 plus 3i, get a number. Don't care what that, okay. Oh, I'm sorry. 9 minus I divided by, I'll get there in a second. Okay, that's the number that we get. Okay, your calculator is converting this to a decimal. We need to make sure that that's the same thing as what we got. So let's type in, put that on parentheses on top. 15 minus 29i, close the parentheses, divided by 13, and voila, the numbers match. Okay. All right, so make sure you are checking your answers if you have time. Okay, next one is foiling. Okay, so first, it's going to give me negative 16 plus 32i plus 22i minus 44i squared. Okay, that's going to be negative 44i squared. I'll go ahead and change that to a positive 44. So 44 minus the 16, that's going to give me 28. 32i plus 22i is 54i. Okay. All right, so here we're just combining like terms. I'm not even going to go through that. Yeah, y'all can do that. 16 plus 8i, nothing to talk about there. Okay, divide. Now here, there's only one term on the bottom, so the conjugate of 9i is negative 9i. Okay, so yes, I'm going to multiply the top and the bottom by negative 9i. When I multiply on top, 6 times negative 9i is minus 54i. 5i times negative 9i is, 5i times negative 9i is minus 45i squared. Okay. Come on, camera, you can do it. Okay, over 9i times negative 9i is negative 81i squared. But remember, these I squareds, change these to positives. So that's going to be a positive 45. I'm going to write that first. Okay, minus the 54i. That's going to change that to a positive 81. Okay, you always got to look to see if you can simplify. Okay, all of these are 54i. All of these are divisible by 9. So if I divide 45 by 9, I get 5. Negative 54i divided by 9 is minus 6i. 81 divided by 9, of course, is 9. And there's my simplified answer, 5 minus 6i over 9. Okay, again, this is just combining like terms. Distribute your negative. I'm not going to go through that and waste y'all's time. Okay, negative 8 plus 13i. Okay, I to the 36, that's divisible by 4. That is a big fat 1. Okay. Foiling here, if I FOIL this out, that's going to give me negative 21 minus 12i. Inside will give me negative 7i. Last will give me negative 4i squared. Negative 4i squared, that becomes a plus 4. 4 minus 21 is minus 17. Negative 12i minus 7i is minus 19i. Okay, that's just combining like terms. 19 minus 12i. Conjugate dividing. Let's multiply by negative 6 plus 4i over negative 6 plus 4i. Same thing. All I've done is multiplied by 1. When I FOIL on top, that is going to give me negative 48 plus 32i minus 12i plus 8i squared. First, outside, inside, last. Make sure y'all can see that. Okay, on the bottom, again, this is a difference of squares. So basically just square the first term and square the last term. Negative 6 times negative 6 is going to be 36. Negative 4i times 4i is negative 16i squared, which changes to a positive 16. Okay. All right, so on top, when this 8i squared, that becomes a negative 8. So negative 8 minus 48, that gives me a negative 56. 32i minus 12i is plus 20i. And then 36 plus 16 is 52. I notice that they're all divisible by 2 at least. Are they divisible by anything better? They're all divisible by 4. Okay, so if I divide all by 4, that's going to give me negative 14 plus 5i all over 13. There is your answer. Okay, last little bit, home stretch, guys. So writing our polynomials. Okay. I'm going to put in here equation because that's what we've been doing in class. Okay, write a polynomial equation. So our equation is going to be set equal to 0. All right, so if my roots are negative 2, 5, and 0, in factor form, I'm going to change the sign, x plus 2, change the sign, x minus 5. X minus 0 is just 0, is just x, right? So I'll slap an x out here in the front. I'm going to set that equal to 0. That's the factored form. And now it's just a bunch of distributing. X squared plus 2x. We'll distribute that to x minus 5. That'll be x cubed minus 5x squared plus 2x squared minus 10x. Combine like terms. X cubed minus 3x squared minus 10x equals 0. Okay, that's pretty easy. All right, so let's try the next one. We've got a root of 3 and 7i, so that means I also have a negative 7i. Okay, so I'm going to write this, flip the sign, x minus 3, and I'm going to have an x minus 7i, and then an x plus 7i. Set that equal to 0. Always, always, guys, multiply the conjugates first, because you want as much stuff to cancel first as you can to make your life easier. But this is just a difference of squares. You ought to be able to do this in your head. Square the first term, x squared. Square the back term, negative 7i times 7i is negative 49i squared, which will change that to a positive 49. And think about this, guys. Let me take 27 seconds. We learned last year in geometry to solve this equation using the square root method. I'll move this to the other side, and I'm going to get x squared equals negative 49. Take the square root, and we said stop, no real solution. But now we know that I pops out. Okay, and the square root of 49 is 7, so isn't this just plus or minus 7i? Okay, so that's why this simplifies to just x squared plus 49. Okay, multiply that times x minus 3. And let's distribute. That's x cubed plus 49x minus 3x squared. Negative 3 times 49, that is negative 120, and then 27, so that's going to be negative 147. And let's rearrange this to put this in proper standard form. X cubed minus 3x squared plus 49x minus 147 equals 0. Now we can check this, guys, okay, with the calculator, as always. Okay, now we can't check this with the equation, but I'm just going to type in my factored form. Let's just type in parentheses x minus 3, x minus 7, second I, parentheses x plus 7, second I, get some number. Okay, so we get negative 1937. Let's type in our simplified answer. X raised to the third minus 3x squared plus 49x minus 147. Oh, look, they match. Okay, move on to the next problem. Okay, we got a root of negative 4 and 5 minus I. So I'm going to have x plus 4, and I'm going to have, now here, since one of my roots has two terms in it, like a 2 plus root 3 or a 5 minus I or something like that, it's going to be x minus, now you don't need the double parentheses, guys. I know one of them is going to be the 5 minus I, and the other one is going to be x minus 5 plus I. If you guys want to skip that step, I'm all right with it. Multiply the two conjugates. Now this is not a difference of squares. Up here is a difference of squares because it was just 7i. This is not a difference of squares because it's 5 minus I, two different terms. So when I multiply the conjugates together, I'm going to have x squared minus 5x plus xi. Oops, sorry. Okay. X times x, x squared, x times negative 5x, x times I is xi. Then I have negative 5 times x is minus 5x. Negative 5 times negative 5 is positive 25. And then negative 5 times I is negative 5i. And then I got to do the last set of distributing. Negative I times x is negative xi. Negative I times negative 5 is positive 5i. Negative I times I is negative I squared, which makes that a positive 1. Okay. Now remember, guys, when you multiply these conjugates together like this, you're always going to have 4 terms that are going to cancel. If they don't, you did something wrong. Negative 5i, bye-bye. Positive xi, negative xi, bye-bye. So now I have x squared, negative 5x minus 5x is minus 10x. And I have this 25 plus 1, so plus 26. All right, and then I'm going to multiply this by the original x plus 4. Okay, so x times x squared, x cubed, minus 10x squared, plus 26x, plus 4x squared, minus 40x. 4 times 26 is plus 104. Okay, and let's combine our like terms. I've got an x cubed I can't do anything with. Negative 10x squared, 4x squared, minus 6x squared. 26x minus 40x is, what's that? It's minus 14x plus the 104. If it asks for equation, guys, you got to have this set equal to 0. All right, last one. We're there. We can do it. Okay, flip the sign. X minus 6. Okay, so I'm going to have x minus 3 minus the root 2. That's one of them. And then I'm going to have x minus 3 plus the root 2. Remember, one of these is positive, one of these is negative. Multiply the two conjugates together first. That's going to give me x squared minus 3x plus x root 2. And then I'm going to do negative 3 times negative 3 times x is minus 3x. Negative 3 times positive, negative 3 times negative 3 is positive 9. Negative 3 times root 2 is minus 3 root 2. And I said this in class, guys, one of the reasons why you learn how to do this, aside from the fact that you may go into a career where you're using polynomials and weather and gaming, apps, wherever polynomials are used, you're learning how to do a whole bunch of math without messing up. Okay, that's a skill. That is a very important piece of the puzzle, one of your tools in your repertoire. Can I do a bunch of math without making a mistake? Okay, that's a very important skill. Or if you do make a mistake, can you go back and catch it? Okay, and then we got to distribute the negative root 2 to each of these. So that's going to be negative x root 2. Negative root 2 times negative 3 is going to be plus 3 root 2. Negative root 2 times root 2 is a negative root 4, which is minus 2. Okay. All right. Some stuff should cancel. X root 2, negative x root 2. Bye-bye. Negative 3 root 2, positive 3 root 2. Bye-bye. So I've got x squared, negative 3x and minus 3x is minus 6x. 9 minus 2 is plus 7. And all of this is being multiplied by our original other factor, x minus 6. Okay, x cubed minus 6x squared plus 7x. Negative 6x squared plus 36x minus 42. Okay, only thing I can combine these guys. So I get x cubed, that's going to be minus 12x squared. 7 plus 36 plus 43x minus 42. Oh, sorry, I can't see that. X cubed minus 12x squared plus 43x minus 42 equals 0. And you can check every single one of these guys. Hope you enjoyed this video. I wish you guys the best of luck on your test, and we will see you next time.